Hello everybody, welcome to YouTube channel. So today we are going to design a PUBG style battle royale game. So we will mostly discuss about the back end of this multiplayer game. PUBG, it's a multiplayer game where 100 concurrent players come together and they are playing into a shrinking map. So the last standing player is the winner of the game, right? So if I talk about the PUBG scale, so in 2018 there were 3.2 million concurrent players were playing at a point of time. So it's a high scale game and it has multiple aspects which I thought like I should be sharing with you guys. So let's move to the functional requirements of this game. So the functional requirements are pretty straight. Functional requirements. So one is that players can join and play. Right. Second would be the because it's a multiplayer game, so we should think about the matchmaking as well. It's a hard the functional requirements which becomes. So we will also talk about the matchmaking, and matchmaking should be fair, and it should be with the similar kind of skill players. It should be based on regional. It should be based on the latency as well. We also want to discuss about the reconnection of the dropped players. So let's say some players are facing some internet issue or they are facing more lag and they switch back to some high bandwidth internet. So they should be able to reconnect to the playing game. Because there can be multiple versions of the game as well. So some player are playing on the older version or some are on new version. So new versions come with the more capabilities. So that support will also discuss about. We will also keep some things out of scope. One is definitely authentication. We will not talk about authentication here. We will also not talk about the history of any kind of, let's say, of games or players, or let's say profile of the players, right? We will also not talk about the friendly matches, like you can do some training and all those things kind of thing as well. So we will not talk about those. Users can follow each other as well. That will not talk about. And the friend, they can make some friends as well to those also. We will not talk about, right? So let's come to the non-functional requirements. So non-functional, I think of is that it's a real-time player game, right? So this game should have a very low latency whenever the users are playing game. So the gameplay event should reach to the server and they should be executed in the lowest time average possible. So we'll keep as that gameplay updates need low latency. I'm thinking approximately 15 milliseconds. Another one is the sorry, fault tolerance. Fault tolerance, we will not talk about as the holistic way. Basically, we know that any system, which basically any system have their master slave strategies, or let's say they have backup servers which can come into play whenever a master server goes down. But we will talk like if let's say game crashes here, right? Game crashes. So how we can bring the game again to the last state where it was, and the all players data should be synced back to the players and they should be start playing from the last state itself. So we will talk about that only. Recover from last state. Right. One thing is the security aspect to this game. So security is very much required here. So in the security, I will not talk about the authentication and all, but I will talk about the duplication of a user. So basically packet injections they can do, right? Or they can, some hacker comes, they do speed improvements. Basically, they are running into the game more than the usual or expected movement speed, right? So these kind of things we will talk about. Another is the scalability of this game. So, like I told you, um, uh, PUBG is a large, scalable, very scaled game. So there could be a 3.2 million concurrent users as well. But it was in 2018 only. So it was a one-time event. But we will think like 1 million players can anytime players can be playing at any point of time, right? That would be our skill here. And the last, I think, is the global support. So it's not like that if you are running the game in India or let's say in US, so the all players playing in the game are based out of US. It could also happen that some are from US, some are from India, some are from some other European country. So those all come together and then they start playing, right? So that aspect also we will try to see here. I'm not going into the APIs and all. We will talk about those APIs and database designs at the time of the diagram. Let's move to the diagram first. Definitely, I'll just move it here. Definitely, we will be having a client here. It's a mobile client, and they have downloaded the applications and they are trying to join the game, and they are hitting APIs through some API gateway. So this API gateway handles all our uh, under the hood things like load balancing and like authentication and some rate limiting also are applied to this, right? So the clients are trying to connect with us through a API gateway. So when you join a game in PUBG style, so you come to a lobby kind of setup there. So the lobby is where you can change the appearance of your player. You can invite somebody. You can make a friend request to somebody, or let's say you do the trainings start from there, and you also join from the lobby itself. So we will be having a lobby service, which is responsible for all the things, but not the gameplay, right? So clients will be connecting to this, and this here they can just call like fetch my profile, or they can request for the join babe, right? So lobby service uh, is responsible to put some clients to basically in some game sessions. So lobby service, when a player basically requests to join a game, lobby service calls a service which is called matchmaking service, and this lobby service also connected to a DB where the user data is available. So I'll just connect it here. So this is connected to a DB, right? And this DB, it would have all the table, like it has a user table which username, and it also have informations like uh one second, like from which region user is there, what are the skill objects for this, the other all information is available there, right? Now, whenever a client requests to join a game, lobby service request a matchmaking for this particular user. So this could be a matchmaking service. So there's a matchmaking service which actually, so when lobby service do this, they say like, hey, start matchmaking for this particular user, and you have all the information for this user. This matchmaking service is actually maintains multiple queues. So these queues are based on the skills, based on the latency of the user, based on the reasons of the user. So let's say if let's say this particular user have a level of 4, So it will be having some queue, and it will be keeping all the players which are in a range of that skill, basically 1 to 5, let's say, and they will keep all the queue users in this particular queue. So whenever a game session starts, it will move all the users with the similar kind of skills to that particular game. Well, so I will say like this is a skill queue for level 1 to 5, right? This will also be having more queues, like it will have a latency queue of, let's say, 100 to 200 millisecond players which are gaming. It will also be having queues like, 1 second, I'll just wait, increase the size of this. It will also be having queues based on the regions also. So this is a region queue, let's say it's a UPU based queue. And all the matchmaking logic would go into this in this server, where there will be some business decisions, like what should be the ways to keep all the similar kind of skill players, or similar kind of this latency players, or a hybrid approach also. So these all logic would go in this logic for matchmaking, right? So once this gets a request and it gets a queue forming up, it returns back lobby service that, hey, I am right now keeping your player into a queue. You just take this ticket ID that, and you can solve. So you keep hold of this ticket ID. I will be sending you back information back that for this particular ticket ID we have spin up the game session. And in parallel, this also actually calls a game fleet. 1 second, I'll just move it here. So it calls a game fleet. So this is the game fleet. We have session fleet, where all the, whenever this a matchmaking service request to this that, hey, I have this particular queue which is about to fill up. Can you give me some game session, or can spin up some game session? So this game session actually is a Dockerized thing where it will it will create a container, and in that container it will spin up a game session. So this game session is nothing but your Unreal Engine binaries, which are customized by the PUBG players, and they are basically put into a S3 bucket. So because we talked about like there could be multiple versions of the game as well. So this S3 bucket holds all the binary of game of Unreal Engine, let's say. Right. So these are based on the versions, or based on the latest information which is available, right? So what this game fleet session do, it just pulls up one binary based on the requirements which matchmaking service provided to it. It will spin up a container and a game session server. There could be multiple game session servers here. Like this is the one. There could be multiple also. Like some, it will give you a good picture here. So there are running multiple sessions here, right? And when it spins up, it basically provides back uh, a port ID on which the game session is running, and the IP address of this particular session container, that so that the users or the clients can connect to this after when they want to send the play events to this. And it also provides a game session ID. Right. I will just move it a little bit here. Right. So once this matchmaking service gets information, it is actually continuously polling, or it could be a connection based on socket as well. Like it is continuously providing it some information that, hey, I want this game session with this requirement. So this will return the game session ID and port and IP address to also to matchmaking service also. So once matchmaking service gets the information, so what it will do, it will basically it will emit a SNS event with this information that, hey, I have received for this particular ticket ID, I have received this information. Then lobby service will consume this SNS event, and what it will do, it will update the user table, user data that, hey, your status, sorry, you have received a port ID, let's say some 8080, and you also received the IP address at let's say 255 dot some ID. So it's an example ID. I'm keeping it here, right? And you also so right. So this also actually updated the ticket ID as well, right? So some base 64 uh, uh, string is generated, and then that is assigned to this user. And this user also have some statuses also, like this status would be like queued when it was queued into the matchmaking service. So at that time, the ticket ID was assigned to this. Sorry, I missed that earlier. And now that it assigned the IP address, port ID, address ID, everything. So it could be like it's in game now. It could be in idle state as well, or it could be like offline as well, right? So though these all statuses are assigned to the user. So once the lobby service get this information and update the user table, so user is continuously polling to lobby service, and in the UI side, if I talk about, there is a timer running on. So they could be polling as well, or we can define a retry after some time as well. Like after 5 seconds, you can ask again lobby service that, hey, any port ID or address, IP address has been assigned to me or not. So once this is assigned, a lobby service will return back this information, a port ID and IP address to this client. Now, client can directly, instead of uh, some API gateway, because they have the port ID and the IP address, they can directly connect with the session. So they directly connect with the game session. And then using this connection, they will start sending events. Right? So the event would be move, shoot, or run. These kind of things, events would be going to the game session. So here, if I talk about, so mostly our functional requirements are going has been satisfied here, right? So all the things are done. So let's move to the non-functional requirements as well. So in the non-functional requirements, if I say gameplay update is low latency. So the one thing is that when client is sending these events, this should be very fast. It should not be happening like the once I click a shoot and after 200 milliseconds or 500 milliseconds, the events is being executed into the game server. So in that case, what it will happen is that user will become bored, right? So they will not try to play this game again ever. So instead of sending it to any TCP protocol or that, we will use UDP protocol here, UDP connection. We will try to send our packets on the UDP connection. So because it's a very fast, so the packets will we will achieve a low latency in this case. Right? There's a problem with UDP connection is that it's not unreliable. It's not reliable. Sorry. So let's say if I send some packets, the packets can lost also. But I think that is okay with me, right? So if let's say I'm sending 1,000 events or 1,000 packets there, and after 1,000 I lost one or two packets or three packets, five packets also. So it is fine with me, but it is not fine with me if let's say every movement, every event is taking more than 200 milliseconds. So in that case, my game will be very laggy and I will lose my interest in that case, right? So here this becomes a very fast. So we resolve the latency problem in this case, right? We also want to talk about the fault tolerant. I think that's the next thing. Yeah. So let's say the fault tolerant in the sense that let's say game session crashes itself, right? So how should we basically recover this? So in that case, what we will do, so whenever the game session is running, so there is a whole object of the game session state, which we can store in some cache. So we will introduce some cache here. So in that case, so game session is every 100 millisecond or 200 millisecond, they are saving their state to the cache. And from this cache, what we can do, we can have a state sync worker, which is actually fetching the data from cache. So basically taking the state of the game, right? And then what they are doing, they are saving it into the S3 bucket. So now this S3 bucket also stores the game states based on the game session IDs, right? So wherever, let's say, one game session is crashed, so there will be some flags which will raise that, hey, game session fleet, this particular game session has been crashed. So now the game session fleet will pull the game state from the here also, and then it will spin up a game session and will bring that state back to this particular state, which was previously of that crashed game, right? Now the user can start continuing the play their game from the last state it was available to. Similarly, there is another thing is that security thing. So I will in the security there are two things. One is the packet injection and speed. So the clients, they can apply some hacking there. Basically, they are moving more than their expected speed, right? Or they are shooting from using some aim boards or using some hack in that matter. So what we can do is that, so we are getting these events. If let's say we start analyzing these events in here and then pass it to the game session, then it will be very laggy. But what we can do is that we allow these events to the game session. And after the allowance, what we can do, we can just have a analytics, basically a tracking system. I will say event tracking system, which is actually getting feed from the game session, and now it is analyzing all the events based on the previous state of the user which is coming, right? And then it can raise some flags to game session itself. So game session will also have some user maps, or let's say user movement maps, where for a particular user ID, if some flags are raised, so it will just throttle the user, or let's say it will drop the user out of the game, right? So that way we can, and this event tracking system also can be used later on, like for skill-based calculations and all. So I will just not talk about those, but yeah, that is the idea, like from where we can get those events, right? Another security aspect is that, let's say, when we do a matchmaking, we get the port ID IP address, right? And this client get this information, and it is directly using the UDP connection connecting with the game session. So there could be a scenario where this client basically being hacked, and there is a duplicate client which is using those port ID and IP address and trying to send multiple packets. Basically, some packets are coming from here, some are coming from here, and this game session is not able to identify like which packet is correctly, right? So it will execute both the packets. In that case, what we can do is that whenever we doing the matchmaking, right? So this lobby service can do one more thing as well. So with the port ID and IP address, it would also send, so it has some cache. It holds the information of the user that, hey, this user is being added to this particular game session. Along with that data, it could also generate some temporary token, access token, if you say. So this temporary token could be like the session ID plus user ID plus some random bits, right? So it will keep information in the cache and it will pass it to the client also. So when the client trying to connect with the game session, so it will also send the token information to the game session. So once it comes to this, so game session can do is that it can connect with this cache and can ask, hey, if this player validate, so it will show the token to this cache, and if the token is present in this cache, it will mark it as received, or let's say expired. It will mark it as expired. And in this game session itself, where the user ID map it was maintaining, it will also maintain, one sorry, it will also maintain the user ID IP address from where the this UDP connection is being created, right? 1 second, I'll just move it over. This, why it is not coming? Yeah, like this. I'll write it here. Wait. Sure. Yeah, so it will maintain these all information here as well. Like this user was validated and it was connected, and the mobile IP address which is it is using to play this game is this one. So wherever the next duplicate client comes, so if even if the it tries to show the token, even the token is also hacked, so it will be marked expired, and also it will say, hey, this duplicate client IP address is not matching with uh, the data which is already in my memory, right? So it will just reject this connection, or it could raise for a auth challenge, like, hey, you need to authenticate again, right? This also solve our that problem. Another aspect is the scalability. So because we have 1 million players of concurrent playing, so what I can think is that the API gateway is auto scalable. We can do this. This is a horizontal scalable service, so we can definitely do multiple lobby service setups here. I will not write it here. I will just remove. DB, we can definitely have a partitioning based DB there. Cache is a distributed cache. I think it's everything we can scale based on the master slave setup, or let's say applying horizontal scale things to this, right? Another aspect is that we need a global support. Yeah, this is the one thing which I want to talk about. So, because in a PUBG game, the users can be in EU, or let's say they can be in NA, right? But they are mashed together, and we need to make sure that they are getting same kind of treatment. Let's say they are getting the same kind of latencies, or let's say they are getting same kind of binary versions. So basically, there should not be any unfairness, right? So what we can do is, I will just move it to upward. Uh, what I'm trying to say is that, let's say some client is in NA, right? The client which is in NA, right? And similarly, there's a client which is in EU, right? And we do a game session, which is a game session, which is in hosted in NA, right? So if client NA is trying to connect with it, it might get a latency of, let's say, 70 milliseconds. And if EU try to connect with it, there would be a thing like it is getting 200 milliseconds. So in that case, it is not fair to the EU clients. So what we will do is, the first approach is that you calculate the average latency of all the players, and then do a game session hosting at some reason that it is in between for both the clients. So basically, it's not hosted in NA, it is hosted in somewhere, some reason, right? And client NA is getting, let's say, 20 millisecond latency here, and EU is also, let's say, getting around 110 milliseconds. So which is similar to that, right? So this is the one approach here. What I'm trying to say is that, let's say, I'll just write a chart here. I created this one. So yeah. So let's say we have mixed regions. Basically, the players are from mixed regions. So what we will do, we will try to calculate the average ping of all the players for a particular region. or let's say various reasons, right? So for let's say Asia, we are getting this much thing from each player. We will calculate like this is the average latency we are getting. For EU, we will getting this one, and for NA, we will getting this one. So what we will do, we will host our game session in EU. So for this particular user, when we hosted in Asia, this was getting 20 milliseconds, but in here 200 milliseconds, and in here 250. So for every region we have this latency, and for user B we have this latency, and for C this latency, right? So we calculated the average. So whatever the average is lowest, we will keep that in there. Another thing is that there is it is applicable in case of AWS only. So AWS actually have some accelerators there, accelerators network. So what it is actually, Amazon have internal network setup. So they have their own cables which are passing by through sea, and so basically uh, the network is not using any public network, right? So they what we can do. So whenever we want to host a session, we can bring some priority clients or priority users to that accelerated network, which is actually using the internal network of the Amazon, right? So the requests are not passing by or they are not going into the public, and so there is no network latency coming to those things, right? So yeah, so this is the design which I wanted to talk about. There is one more thing which I think let's I will just say. So because there are some assets to the game as well. So basically, you have animations in the game, you have the videos in the game, you have multiple images also. So we can also have a CDN. Once again, I'll just increase the size. So we can also have a CDN here, um, which is actually hosting the assets, game assets, right? And this client can directly connect to the CDN, and this CDN is actually fetching the data. One second. Launch. I just reduce the size. Yeah. And this CDN is directly fetching the data from S3 buckets where it was hosted up here, right? Yeah. So this is the pretty design. Just let me know if you feel something I left. I try to do it in a very hurry phase so that you don't have to spend much time to my video. But just I will request you to, if you like something, just tell me in the comments. If you don't like anything, please tell me in the comments so that I can improve on the things. Okay, see you with the next design later on. Thank you very much. Bye bye.